Hello and welcome. Uh, I'm trying to study differential geometry, and I must say it's really not going all that well. And one of the things that I keep tripping over is the notation because I just don't have a background to ever have run into most of this notation. So what I did was I went through the books I have and wrote down all of these symbols I've been trying to read. I looked them all up, wrote little descriptions about them, little examples about them, and made a notebook of it. So I keep it with me with my books. So when I'm studying, and it's been really useful to me. So I thought, hey, someone else might get some use out of this. So I thought I'd make a short video and see if it's useful. And warning, this is pretty boring stuff. Okay, the very first thing is so simple. What is a set? It's got these little squiggly brackets here. So this is set A, and it is a collection of something that is not is does not repeat. So the set A is 1, 2, 3. As an example, that's a set. That's all there is to it. What is a union of sets? So you would read this as the union of set A and set B. You would write like this, with the U stands for union. That's logical. So if you have set A has 1, 2, 3 and set B has 2, 3, 4, we see that some of these repeat 2 and 3 here and 2 and 3 here. Well, you don't write them down twice. You just write down what's unique. So it's 1, 2, 3, 4 is the union of set A with set B. There's a lot of set theory in differential geometry. Okay, what is a subset? Well, it's exactly like it sounds, right? So A is a subset of B, as in if A is 1, 2, 3 and set B is 1, 2, 3, 4, then you see that this is a piece of that. So A is a subset of B because every element in A is also in B. That's logical. Excuse me. Okay, what is the complement of a set? Now, this is new to me. Let's go to the example because the words are they're just words. Okay, so we have a universal set is all prime numbers up to 25, and then we have a set A. So we want to find the complement of set A. So the way we define that, the complement of set A is A prime is equal to the universal set minus the set. So we write down the universal set, write down the set, subtract them. You see that 2, 3, 5. So that's, I don't know if that's really a subtract sign. It's a remove sign for sure. So we remove it from this set, and here's the complement of the set. I'm not sure what I'm going to do with that, but it is in there. What is the element? Even I knew this one. That P is an element of set A written as P element A. Example would be this easy. A is a set of 1, 2, 3, then 2 is an element of A. I think we all knew that one. Now, what does this vertical bar dunk mean? This is new to me. It means the vertical bar typically represents such that. So when you see this vertical bar in a notation equation in your mind, you just say such that, like this. So this is a set where P is the element of A such that it must meet the condition that P is greater than 0. Okay? So that's pretty straightforward. What is a Cartesian product? This is brand new to me also. Okay? And here's a bunch of words. Let's look at the example. So if we have a set A of 1, 2 and set B of little a, little b, then the Cartesian product A times B, I don't know if you call that times or cross. I don't know what you call it. It's just 1A, 1B, 2A, 2B. So that's pretty straightforward. Also, once again, I'm not sure what it's for. Everybody knows what this one is. What is R? The set of real numbers. What is Rn? The set of n tuples of real numbers. First time in my life I've ever used that word. Sounds like something I'd do after too much fun. I'd tuple over. So, example, R2 is 2 dimensions, R3 is 3 dimensions, R4 is the space-time we use in general relativity. Okay. What does this mean? This is new to me also. So you got a colon and an arrow. Okay, this says that f is a function. F is a function that maps from set A, the domain, to set B, the codomain. Here's an example, and I hope I got this right. If I didn't, would someone please jump in on it and tell me? So let A be in R and f of x is equal to 2x, where the domain of f is restricted to integers. Okay, so we just got integers 1, 2, 3, 4, 5. Then f is a map of all integers domain to all even integers, because for every value of x in A, we get 2x in B. So it's all even integers, the codomain. I hope that's right. That's why I understood it. Okay, here's one of the last ones. I run into this one all the time. What is TPM? Okay, this is a manifold, and this is T is the tangent to space. So TPM is the set of all vectors tangent to M at point P. So this is a tangent space. And here is a picture that's worth 1,000 words. All right, so we got R3, Euclidean. We've got a manifold, right? So at this point P, we have a plane that touches at that point. So this is a two-dimensional plane that touches at that point. So this plane is a tangent space, and it's written like this. Okay, so these are all the ones I've got done so far, and they've helped me. I keep referring back to them. Here's where I got all this stuff, and thanks for watching. I'll see you later.